The main thing was kind of getting the period right? Okay. Okay, this is very, very, very important.
We in 4-7.
4-7. This is not hard unless you make it hard. But you have to do what I say, right? You have to hear what I say, and you have to do what I say. You can't go do it some other way or your own way, okay? We're going to look at inverse trig functions. Okay? So, like I could say that sine of theta is equal to 1. Okay? Sine of theta is equal to 1. Can the sine be equal to 1? Where does the sine equal 1?
It's 0.
It's 0. And so what do you know? Theta is equal to what?
0.
Oh.
You just said it.
Oh, 0.
0. Okay. If I told you sine of theta equal 1, then you know theta is equal to what? 0. Okay. So you understand that, right? But this is the actual function. What would I do to both sides? I would take the sine inverse. And then sine inverse of 1. Okay? Now, sine inverse is not 1 over sine. Okay? Fatima, tell me what sine inverse is not.
1 over sine.
It's not 1 over sine. Sierra,
Yes.
tell me something about sine inverse.
It is not 1 over sine.
It is what? Unsigning. It's undoing the sine operation. Yes? Okay. So if I have sine inverse of sine, if I'm unsigning the sine, what am I left with?
Theta.
Theta. So theta is equal to what? Sine inverse of 1. Okay? So you all get your calculator out.
Nothing.
What?
9.
Oh yeah, we messed up, didn't we? Where does sine equal 1 at 90? Yes?
Yes.
Okay. We thought 0. We did 0. Okay. Right. So does everybody agree that the sine of 90 is 1? Do you have your calculator?
I left it at home.
Bring your calculator every day. Okay. Sine inverse of 1 is what, Anthony? 90. Okay. Now how do we know that? Okay. This is 360. This is 180. This is 90. Okay. So tell me what sine inverse does, Austin. How would you describe sine inverse?
Undoes the sine.
It undoes the sine. Okay. Another way to do this is if I say sine inverse of square root of 2 over 2 is equal to what? When I say sine inverse of square root of 2 over 2, tell me a way that you could look at this. How could you think about this?
Think about it on the unit circle.
Think about it on the unit circle. And what are you asking? This is the question that this is saying, and you have to understand this. What angle has a what? What angle has a sine of what?
1.
No.
Square root of 2 over 2.
Square root of 2 over 2. Okay, so if I say sine inverse of 1/2 equal, tell me in words, Sierra, what I'm asking for.
What angle has the inverse of sine?
What?
It's right here.
What angle has a sine of 1/2?
1/2. Does that make sense? What angle has a sine of 1/2?
Square root of 3. Oh,
What? That's not an angle.
30.
Okay, right. So if you think of it, sine is y, 30 degrees. So that is 30 degrees. So if you have sine inverse, the angle, the answer should be a what, Austin?
An angle.
An angle. The answer should be an angle. Because I'm asking, what, Sierra?
What angle has a sine
Okay.
of?
And same thing, if I had cosine inverse of 1/2 equal, tell me what that question is, Anthony. Say that in words.
What angle has a cosine
Of 1/2. Yeah, okay, got it? All right, now, this is where it gets a little confusing. If I say, what is sine inverse of 1/2, okay, you think, somebody told me to think about the what?
Unit circle.
Okay, and what did you just tell me, looking at the unit circle? What's the answer?
30 degrees.
Is equal to 30, okay? Why is it not, okay, also understand this is the exact same thing as sometimes it is called arc sine of 1/2. Arc sine and sine inverse are exactly the same. Arc sine and sine inverse are exactly the same. Okay? Now, when I said, what is sine inverse of 1/2? Anthony said 30. And that's an angle. And so that's an answer. Why is it not quite that easy? Sine is what? Why? Do you see anything else that could happen?
Negative.
Be in the other quadrant.
Right. Now, not negative, because sine 30, like if I came down here, right, negative 30, sine is not 1/2, sine is what?
Negative.
Say it.
Negative 1/2.
Negative 1/2.
And then
But what happens over here at 150?
positive 1/2.
Yeah. So sine inverse of 1/2 could also be equal to what? 150. Do you see that?
Mm-hmm.
Okay. So another way to look at it would be this. If I draw the sine wave, I would go 0 to what? 360. Then this is 180. This is what?
90.
90. This is what?
270.
270. And then this is sine. Okay. You could look at it this way. If this is 1/2, I have how many values have a sine of 1/2?
2.
2. And this one would be what?
30.
30. And this one would be what? 150. 30 from 180. So do you see, this and this both tell you that there is more than one solution. Okay? So if I say sine inverse of 1, and sometimes like if I say just like sine inverse of 1, then that's equal to 90, right?
Mm-hmm.
Now, on that one, how many solutions is there?
1.
1. And you can see that on the unit circle too. Where is y equal to 1? Only right here. But if I said 0.9, there would be a solution here and a solution here. Does everybody understand this?
Yes.
Okay. Since sine of theta is periodic and not unique, there can be more than one solution. Okay? So if I say, and let's do this one in radians, just so that we get good in radians. What if I say sine inverse of the square root of 2 over 2 is equal to, okay, on that one, how many solutions are there, Anthony? 2. One here and one here. Okay? Because this is a y value of the square root of 2 over 2. And a y value of the square root of 2 over 2. And if you look at your unit circle, you'll see that, right? Okay. How many, what is this one in radians? This is how many radians?
Pi over 2.
Pi over 2 is right here.
No. Pi over 4.
Pi over 4. Okay. Sierra, where is this one? What is this angle here? What?
I'm doing it in my head. Wouldn't it be 3 pi over 4?
3 pi over 4, I think is right. And how would we do that? You know that you have to back off by pi over 4.
Yes.
And so this is 4 pi over 4 minus pi over 4 is 3 pi over 4. So you have two solutions. Pi over 4, and then the other solution is 3 pi over 4. Okay, two solutions. Okay? Now, where would another solution be? We could add how much to this and get another set of solutions? Plus 2 pi, right? Because if we repeat, I'm going to have a solution here and here, and then what?
There.
Over 2 pi and over 2 pi. So we would have it at, let's say if this is 8 pi over 4, I would have one at where 9 pi over 4, and then I have 2 pi is what? 8 pi over 4 plus 3 pi over 4 is what?
11 pi over 4.
Okay, so I have 2 in the unit circle, and then they repeat every 2 pi. Okay, does that make sense? So, to answer the question, okay, and you guys have to see that you have to do this, okay? This is very important. Sine inverse of the square root of 2 over 2. The solutions are going to be what? The first one is pi over 4 plus every what? 2 pi. Right. So you would say n is what? Any integer times what? 2 pi. And that's saying it's going to get which one, Sierra? This one,
And then
right? And going both ways because n is an integer. What would my second group of them be, Austin?
3 pi over 4 plus n times 2 pi.
N times 2 pi. N times 2 pi. Okay. Those are the solutions. Pi over 4 plus n 2 pi, 3 pi over 4 plus n 2 pi. When I say sine inverse, I'm looking for a what?
An angle.
An angle. And here I'm giving the angle in
Radians.
radians. Does that make sense? Okay. N is any integer. This is easy if you don't make it hard. Okay? Now, if you put in your calculator sine inverse of the square root of 2 over 2, what does it tell you?
$45.
45. Okay. So this is two different ways to answer the question, and on the homework you have to make sure which one it's asking you for, and you have to answer it that way. This is the general solution. And this would be sort of like all solutions. Okay? And so let's look at this sine inverse of the square root of 2 over 2. The general solution would be what? Pi over 4 plus 2 pi n, and 3 pi over 4 plus 2 pi n. Okay? That is the general solution. Okay. The other one is the calculator solution. The calculator solution is the domain solution. Okay? Because sine and cosine, for one cycle, there's a domain for that one cycle. Okay? And so what you have to see is that the domain for sine inverse of theta is between minus pi over 2. Okay. Sine inverse that the calculator gives you is between minus pi over 2 and pi over 2. Cosine inverse of theta is between, is between 0 and pi. Okay, and tangent inverse of theta is between minus pi over 2 and pi over 2. So what this is saying is sine, if it's asking you for sine inverse, which quadrants does it want? If we're looking at the domain, which quadrant, Sierra, if it's sine inverse?
Wouldn't it be the left side of the
What?
circle?
Tell me, what is this quadrant,
Okay.
Sierra? What is this quadrant?
Quadrant 1,
What is this?
2,
What is this?
3,
What is this?
4.
Okay. Sine inverse wants quadrant what?
2 and 3. No,
Minus pi over 2 is where?
the bottom.
And pi over 2 is where? So what it wants between there and there. So that's what?
1 and 4.
Quadrant 1 and quadrant 4. Okay. Cosine wants what, Austin?
Between 0 and pi.
And pi. So cosine inverse wants the answer between where and where? I mean, in which quadrants?
Quadrant 1 and 2.
Okay. Do you see that this gives you a unique solution? Because what does cosine look like between 0 and pi? It looks like that, right? There's only how many solutions? 1. Sine between minus pi over 2 and 2 looks like what? Like this, right? How many solutions are there?
1.
1. Okay, so do you see that if you want a single solution, you have to look in the domain, and in the domain, there's only one solution. So what is the domain of the sine inverse?
4, 1.
The domain, though, is what?
Oh, negative pi over 2 and 2 pi over 2.
That says pi, negative pi over 2 and pi over 2. Okay. What is the domain of the cosine inverse, Anthony? 0 and pi. Okay. So, if it tells you to do it generally, how do you answer it? Or all solutions is what? That. If it wants the domain solution or the calculator solution or the primary solution, you do what? You look at the domain and pick the one in the domain. Okay. So, when people get a 50 on their homework, it's going to be because they did what? They did not the one that they were asking for. Does that make sense?
Sure.
Okay. And you're going to go through and you're going to do them all, and then they're going to be wrong if you're not thinking about this. Okay? So, this is why you need to have the unit circle memorized so you can do these really easy. Okay, if I say sine inverse of minus 1/2, okay, tell me what it's asking.
What is the angle of sine of negative?
No. What is the angle that has a sine of negative 1/2? Okay. So I'm not going to get through this lesson if I try to get you guys to answer, so I'm just going to kind of go through it, and then you'll have to figure out, because I'm not going to get through the lesson because people are not answering me. Okay. So if I say, what is sine inverse of minus 1/2, what you can see from the unit circle is that, look on the unit circle, it would be 11 11 pi over 6. Okay, because sine is between pi over 2 and minus pi over 2. And if I look at 11 pi over 6, that's like minus pi over 6, or 11 pi over 6. That is the answer because that is what is in the domain. Okay, 11 pi over 6
So
is
do
what?
you do offer all solutions in that case?
No, it just, I'm saying what's the primary solution?
Okay.
And the primary solution is there. Now, where would the other solution be? There's another solution here, okay, and that would be pi plus pi over 6, okay, so it'd be like 7 pi over 6. But in the primary one, it's between here and here. So you have to think about the domain if you're going to give the right one, okay? So if I have sine inverse of the square root of 3 over 2, that's going to be equal to pi over 3, okay? And why do we say that? Because that is like, this is pi over 6, and then this is pi over 3. And so the positive sign would be in the first quadrant, okay? Now there's another one over here, but on sine inverse we want quadrant 1 or quadrant 4. All right. Same thing with tan inverse. You have to think about where your domain is. And on tangent inverse, the domain is between minus pi over 2 and pi over 2. Okay. For values not easily found on the unit circle. Okay. So what are things that I can do on the unit circle? I can do 30. I can do 45. I can do 60, I can do 90, I can do 0, and then I can this sort of begins to repeat, like, right, this would be like 90 plus 30 would be 120, 135,
180.
Okay.
150.
150 and 180. Or you could kind of think of this as pi over 6, this is pi over 3, this is pi over 2, and what's this one, Austin? Pi over 4. Yeah. Okay. And then these repeat. These are the ones that are easy on the unit circle. What happens if they give you one that is not on the unit circle? You use your what?
Calculator.
Your calculator. And you use the cosine inverse. Okay. Cosine inverse is not what?
Cosine, or one of
It's not 1 over cosine. It's swatting.
Undoing the cosine.
Uncosining, undoing the cosine. Okay, it is undoing the cosine. All right? So, this is kind of what you have to see. If I have f inverse of f of x, what do I just end up with? I'm effing and then I'm uneffing. What do I end up with? X. Okay. Or if I have f of f inverse of x, that's equal to x. Okay. So if I have sine inverse of sine of theta, that's just equal to theta. So I want the sine of theta, and then I want to know what angle has a sine of the sine of theta. Well, it's theta. Okay, so you're just undoing it. Okay? You must keep track of domain and range. You must keep track of domain and range. Okay? So if I have sine inverse of sine of 3 pi over 2 is equal to sine inverse of -1. Okay? So the sine inverse of -1, what is the domain of this? It's between what and what? Yeah, the domain is between minus pi over 2 and pi over 2. Okay? And so if I say sine inverse of sine of 3 pi over 2, okay, what you have to see is that this is, what has a sine, what is sine of 3 pi over 2? What is sine of 3 pi over 2?
-1.
Okay, -1. All right. What is sine inverse of -1? It's what?
270.
What are we working in?
Radians, 3 pi over
Okay. But is that the right answer? Is 3 pi over 2 the right answer?
2. Unsine. No, because the domain.
So what does the domain tell you it has to be?
Pi over.
This is the point, right?
Yes, sir.
Okay. So 3 pi over 2 is good, but it's not in the what?
Domain.
What is in the domain? Minus pi over 2. Okay. Somebody better ask me a question or I'm going to go on. What is the domain of sine?
Negative pi over 2 to pi over 2.
Okay. So if I get 3 pi over 2, why can I not answer it 3 pi over 2?
It's not in the domain.
So what value is in the domain?
Negative pi over 2.
Is it exactly the same point?
Yes.
So when you answer this, like if I say sine inverse of sine of 3 pi over 2, you're going to be tempted to just write what, Anthony? 3 pi over 2. And when you write that, you're going to have to stop and tell yourself, whoa, what's wrong?
It's not in the domain.
So how can you write 3 pi over 2 in the domain?
You're going to negative pi over
Right. It's still the same point, but how do you answer it? Negative pi over 2. Okay. So let's look, and also understand arc sine is the same thing, so I'll just work one saying that. Okay. So I want to know what the arc sine of the sine of 5 pi over 3 is. Okay? So where is 5 pi over 3? Does nobody have the unit circle memorized?
In fourth quadrant.
It's in the fourth quadrant.
No, sorry, third.
It's in the third quadrant. Okay, and where is it? Is it this one or is it this one?
Right between them.
It's what?
Right between them.
Okay.
No, it's in the fourth quadrant.
Oh,
300
3,
degrees.
sorry.
Okay. So it's 300 degrees, which would be like this, right?
Yes.
Okay. So this is 5 pi over 3. All right. Then what would this be?
Would be negative pi over 3.
Negative pi over 3. So how do I want to answer this? I want to answer it as 5 pi over 3, but I better answer it as what, Anthony? Negative pi over 3 to be in the domain. Okay, so in order to be in the domain, that's how we have to do it. All right, I'm going to show you a couple of other problems that you have to be able to do. So if it's arc sine and sine, or arc cosine and cosine, all you have to do is just make sure you get the what right.
Domain.
Right. So you know the answer is 5 pi over 3 because you're unsigning the sign. It's 5 pi over 3, but you have to answer it in the correct domain. So these problems like this are what?
Easy if you don't make them hard.
Easy if you don't make them hard, and you got to remember the what?
Domain.
You got that? Okay. The ones that are harder is...
So why is it negative pi over 3?
because that is the domain for sine. It has to be between pi over 2 and negative pi over 2. You have to give the answer that is within the domain. Okay, these are the harder ones. What is tangent of cosine inverse of 2 over 3? All right. Why is this one harder than the other one?
You can't just
Tan.
I'm tanning the uncosine, right? So that doesn't just drop out, does it? So I need to draw the what?
Unit circles.
Almost, but I need to draw not the unit circle, but the triangle. It's just that it's not going to be a unit, okay? So we have to remember that cosine is what? Oh, what? So cut. What? Adjacent over hypotenuse. So if I draw it, since this is cosine, the adjacent is what? 1, 2. This is the adjacent. The hypotenuse is what? 3. So this is 2 and this is 3. Okay. Now if it was negative 2 over 3, I better draw it over here. Right? I better draw it over here. Okay? So it's 2 over 3 positive. But there is another value, right? What's the other one? You could be down here, right? This is still 2 and this is still 3. Okay? Now, what should I probably go ahead and do? If this is 2 on either one of those, I can calculate what? What's the third side? Square root of 9 minus what? 4 is the square root of what? 5. Okay. So cosine inverse of 2 over 3 is going to make this triangle, and this would be minus the square root of 5. Okay? So if that's the triangle, what is the tangent? Tangent is what?
Opposite over adjacent. I mean, yeah.
Opposite over adjacent. So what is the opposite?
Square root of 5.
Square root of 5 over, what is the adjacent? 2. Now, there were 2 solutions, so let's make sure that we are the right one. Well, it's got to be positive, and so I think that we are right here. It's the square root of 5 over 2. Because if I use this one down here, the tangent would be negative. Okay, so it's the square root of 5 over 2, and if I look at tangent, I'm in the right quadrant there, and it's positive. Does that make sense? Okay, so if I have one that is not just unsigning the sine or uncosigning the cosine, I've got to draw a what?
Picture.
A triangle. And I use the 2 numbers to label 2 sides, and then how do I get the third side? Pythagorean theorem. And then you look at the outside, the tangent is what? Opposite over adjacent, square root of 5 over 2, paying attention to the domain. Okay? So, this is Pre-Calculus, Chapter 4, Section 7. Okay, so this is due Wednesday. Due Wednesday is what? 5 through 18, 21 through 38, 41 through 46, and the bonus is 104. Okay, 5 through 18, 21 through 38, 41 through 46, bonus is 104. Okay, on day 2, I'm going to give you another set of homework that's going to be due Thursday. I don't have enough room to write it up there. And then the test is going to be when? Thursday. Okay, so this homework is due tomorrow, another set due Thursday, and then the test is when?
Thursday.
Okay, because we don't have time for a test on Friday. All right? It's a half day. Half day. Okay, so what do we got? Homework and test on Thursday.
Right.
Test on Thursday will probably be the chapter test. Okay.